so sorry I am late today. I lost track of time. I was actually cooking myself some snacks while I was just got a little late for me. So let's go ahead and get started. So for those of you that weren't with us the last time, we are in a submarine in the turn of the century. The main character is Professor Aronow, and he's been getting the tour from the captain, Captain Nemo. So welcome back. Sorry I'm late. Mysterious second person, please introduce yourself. Yes, who are you, El Pepe? Hi, I'm glad you're here. Please tell me your name. I can't tell from that little tiny screenshot who you are. All right, well, when you're ready. In the meantime, chapter 12, entirely by electricity. So one thing to, Jose, I miss you. I mean, I kind of never thought I would say it, but I miss you. So hope you've been good. Hope you've been safe. Don't get the Rona. Sir, Captain Nemo said, showing me the instruments hanging on the walls of his stateroom. These are the devices needed to navigate the Nautilus. Here, as in the lounge, I will always have them in front of my eyes, as they show me the position and exact heading in the midst of the ocean. You're familiar with some of them, such as the thermometer, which gives us the temperature inside the Nautilus, the barometer, which measures the heaviness of the outside air and forecasts the change in the weather, the humidistat, which shows the degree of dryness in the air, the storm glass, whose mixture decomposes to announce the arrival of hurricanes, the compass, which directs my course, the sextant, which takes the sun's altitude and tells me my latitude, chronometers, which help me calculate my longitude, and finally spyglasses for both day and night, allowing me to scrutinize every corner of the horizon at once when the Nautilus rises to the surface. These are your normal navigational instruments, I replied, and I'm familiar with their uses. But no doubt these others answer to the Nautilus' special needs. That dial I see there, with a needle moving under it, is it a pressure gauge? It is indeed the pressure gauge. We put it in contact with the water, and it shows out the outside pressure of the hull, which in turn gives me a depth as to where the submersible is traveling. Are these some new breed of sounding line? They're thermometric sounding lines which report the water temperatures at different strata. And these other instruments, whose functions I can't even guess. Here, Professor, I need to do a little bit of explaining, Captain Nemo said. So kindly hear me out. He fell silent for a few seconds, then said, There's a force of powerful, obedient, quick, and effortless that can be bent to any use, that reigns supreme on board. My ship runs entirely on this force. It lights me, heats me, and it's the soul of my mechanical equipment. That force is electricity. Electricity, I exclaimed in surprise. Yes, sir. But, Captain, you have tremendous speed of movement that doesn't square with the strength of electricity. Till now, the dynamic potential has been very limited, capable of generating only small amount of power. Remember, this is in the 1800s, so they basically, electricity is good for like turning on lights, but not a whole lot else. They're still using coal and steam power for everything else. Professor, Captain Nemo replied, my electricity isn't the run-of-the-mill variety, and with your permission, I'll leave it at that. I won't insist, sir, and I'll rest content with simply being flabbergasted at your results. I would like to ask one question, however, which you needn't answer if it's out of line. The electrical cells that you use to generate this marvelous force must run down very quickly. The zinc, for example, how do you replace it since you're no longer in contact with the shore? That question I'll answer, Captain Nemo replied. First off, I'll mention that at the bottom of the sea there are veins of zinc, iron, silver, and gold that I would quite certainly be capable of mining. But I haven't tapped any of these terrestrial metals. I've chosen to make the demands only of the sea itself for the source of electricity. The sea itself? Yes, Professor, and there are no shortage of such sources. In fact, by establishing a circuit between two wires immersed in different depths, I could have obtained electricity from divergent temperatures they experience. But I prefer to use a more practical procedure. And what's that? You're familiar with the composition of salt water. In 35 ounces, you'll give 96.5% water and about 2.66% sodium chloride. Then small amounts of magnesium chloride, potassium chloride, magnesium bromide, sulfite, and of magnesia, calcium sulfate, and calcium carbonate. So you can see that sodium chloride is found here in significant proportions. Then it's this sodium that I extract from salt water to make my electrical cells. Sodium. Yes, sir. Mixed with mercury, it forms an amalgam that can take the place of zinc in the Bunsen cells. The mercury is never used up. Only the sodium is consumed, and the sea itself gives me that. Beyond this, I'll mention that the sodium batteries have been found to generate greater electricity, and their electromotor strength is twice that of zinc batteries. Captain, I fully understand the value of sodium under these conditions, and the sea contains it, fine. But it still has to be produced. In short, it has to be extracted. And how do you accomplish this? Obviously, your batteries could do the extracting, but if I'm not mistaken, the consumption of sodium needed by the electrical equipment would be greater than the quantity that you extract. So in the process of making your sodium, you would use up more than you make. Accordingly, Professor, I don't extract it with batteries. Quite simply, I utilize the heat from mineral coal. Mineral coal, I said, my voice getting up in words. We'll say sea coal if you prefer, Captain Nemo replied. And you can mine these seams of underwater coal. You'll watch me work them, Professor Aronel. All I ask is a little patience, and you'll have time to cultivate the virtue. Just remember this. I owe everything to the ocean. It generates electricity, and electricity gives me and the Nautilus heat, light, movement, and in a word, life itself. But not the air you breathe. Oh, I could produce the air needed on board, but there wouldn't be any point in it, since I can rise to the surface of the sea whenever I like. But even though electricity doesn't supply me with breathable air, it at least operates the powerful pumps that store it under pressure in special tanks, which in a pinch will allow me to stay underwater at lower strata for as long as I want. So, quick note, some of this stuff is real, some of this is not. So, as far as the sodium chloride and mercury being used to create electricity, no, like that's science fiction that will never power enough for like an entire submarine. But this other thing is true. So as far as oxygen, like in order to be stored, has to be stored under pressure in tanks. That's something that he sort of, the author figured that out, and it was sort of like advanced science at the time, and he used it in the book to give it a little bit more realism. Captain, I replied, I'll rest content with marveling. You're obviously found what all mankind surely wants to find one day, a true dynamic power of electricity. I'm not so sure they'll find it, Captain Nemo replied icily. Be that as it may, you're already familiar with the first use I've discovered for this valuable force. It lights us, and with a uniformity and continuity not offered even by sunlight. Now, look at this clock. It's electric. It runs with the accuracy challenging the finest chronometers. I've had it divided into 24 hours like Italian clocks, since neither day nor night, nor sun nor moon exist for me, but only this artificial light I import into the depths of the sea. See, right now it is 10 o'clock in the morning. On the dot. Another use for electricity. That dial hanging in front of your eyes shows how fast the Nautilus is going. An electric wire puts it in contact with a patent log. This needle tells me the actual speed of my submersible. And, hold on, just now we're proceeding at a moderate pace at 15 miles an hour. It's marvelous, I replied. And you're so right to use this force, Captain. It's destined to take the place of wind, water, and steam. But there's more, Professor Aronel, Captain Nemo said, getting up. And if you'll kindly follow me, we'll inspect the Nautilus stern. In essence, I was already familiar with the whole forward part of this underwater boat. Here, the exact subdivisions from going amidships to its spur. The dining room, 16.5 feet long, separated by the library by a watertight bulkhead. In other words, it couldn't be penetrated by the sea. The library, 16.5 feet long. The main lounge, 33 feet long, separated by the captain's storeroom by a second watertight bulkhead. Aforementioned stateroom, 16.5 feet long. Mine, 8 feet long. Finally, air tanks, 24.5 feet long and reaching up to the stem post. Total of 115 feet. The doors cut in the watertight bulkheads closed hermetically and with the help of India rubber seals, which ensured complete safety aboard the Nautilus if it should spring a leak. So at the time, all rubber came from India. I followed Captain Nemo down corridors located close at hand, and I arrived midships. There I found a kind of shaft heading upwards between two watertight bulkheads. An iron ladder clamped to the wall led to the shaft's upper end. I asked the captain what the ladder was for. It leads to the skiff. What? You have a skiff? I remarked with some amazement. Surely. A first-class longboat, light and unsinkable. We use it for excursions and fishing trips. But when you want to set out, don't you need to get back to the surface of the sea? By no means. The skiff is attached to the top side of the Nautilus's hull, and it occupies a cavity designed specifically to hold it. It's completely decked over, absolutely watertight, held solidly in place by bolts. The ladder leads to a manhole cut in the Nautilus's hull, and corresponding to a similar hole cut in the skiff's side. Through this double opening, I insert myself into the longboat. My crew close up the hole belonging to the Nautilus. I close up the hole belonging to the skiff merely by tightening the screws. I undo the bolts holding the skiff to the submersible, and the longboat rises with prodigious speed to the surface of the sea. Then I open the cover panel, which has stayed carefully closed until this point. I up my mast and hoist sail, or take out my oars, and I go for a spin. But how do you come back to the ship? I don't, Professor Erno. The Nautilus comes to me. At your command, at my command. An electric wire connects me to the ship. I fire off a telegram, and that's that. Right, I said, dazed by all these wonders. Nothing to it. After going past the well of the companionway led me to a platform. I saw cabin 6.5 feet long, which Conseil and Ned Land, enraptured in their meal, were busy devouring it to the last crumb. Then a door opened to the galley, 10 feet long and located between the vessel's huge storage lockers. There, even more powerful and obedient than gas, electricity took care of all the cooking. Wires under stoves transmitted to platinum griddles heat was distributed and maintained with perfect consistency. We would call this a conductive surface. So like they sell them at some stores as those sort of like little electronic burners that you just plug it in and you can use it as like a stovetop. So that actually was invented later on. It also heated a distilling mechanism through the evaporation process, supplied excellent drinking water. Next to the galley was the bathroom. Excuse me, conveniently laid out, with faucets supplying hot and cold water to all. After the galley came the crew's quarters, 16.5 feet long. But the door was closed and I couldn't see its furnishings, which might have told me the number of men it took to operate the Nautilus. At the far end stood a fourth watertight bulkhead separating the crew's quarters from the engine room. The door opened and I went into the compartment where Captain Nemo, indisputably a world-class engineer, had set up his propulsion units. Brightly lit, the engine room measured a good 65 feet in length. It was appropriately divided into two parts. The first held cells for generating electricity, and the second, the mechanism that transmitted motion to the propeller. Right off, I detected the odor permeating this compartment, and it was sueur generis, which is in a class of its own in Latin. Captain Nemo noticed the negative impression it had on me. The gaseous discharge is caused by the use of our sodium, he told me, but it's only a mild inconvenience. In any case, we cleanse the ship every morning by ventilating it in open air. Meanwhile, the Nautilus's engine I examined the Nautilus's engine with an interest that you can easily imagine. You'll note, Captain Nemo told me, that I used the Bunsen rather than the Rumperov cells. The latter would be ineffective. Bunsen cells are fewer in number but large and powerful, which makes them superior in my experience. The electricity generated here proceeds to the stern, where electromagnets of huge size activate a special system of levers and gears that transmit motion to the propeller shaft. The latter has a diameter of 20 feet, pitch of 24.5 feet, and can do up to 120 revolutions per minute. And you get a speed of 55 miles an hour. Here lay a mystery, but I didn't insist on investigating it. How could electricity work with such power? Where did this nearly unlimited energy come from? Was it some kind of new high-voltage induction coil? Could this transmission be immeasurably increased by some unknown system of levers? This was the part that was beyond me. Captain Nemo, I said, I can vouch for the result, and I won't try to figure them out. I've seen the Nautilus in operation near the Abraham Lincoln. I know where I stand on its speed, but it isn't enough just to move. We need to know where we're going. We have to be able to steer up, right, left, and down. And how do you reach lower depths? When you meet an increasing resistance that's measured in hundreds of atmospheres, how do you come back up to the surface of the ocean? Finally, how do things stay at whatever level suits you? Am I out of line in asking these things? Not in the least, Professor, the captain answered me with a slight hesitation, since you'll never leave this underwater boat. Come to the lounge. It's actually our workroom, and you'll get the full story of the Nautilus. All right, guys, that's it for today. I hope you guys have a great weekend. Jerry, I hope you have a great weekend. And I'll see you guys 3 o'clock on Monday. See ya.